The National Electrical Code, or NEC, does not have specific regulations dedicated solely to the fill of stub-throughs. However, there are general requirements that can be applied to ensure safety and compliance. When dealing with conductors within a stub-through, a key guideline to remember is the fill should not exceed 40% of the cross-sectional area of the stub-through itself. This limitation helps prevent overheating and potential damage to the cables due to overcrowding. Now let's discuss conduit. If the stub-through is considered part of a more extensive conduit system, the fill requirements change slightly. For conduits that are 600 mcm or less, the fill should not exceed 40%. However, for conduits that are larger than 600 mcm, the maximum fill is reduced to 30%. This difference accounts for the increased potential for heat buildup in larger conduit systems. The determination of whether a stub-through is considered a conduit system often comes down to interpretation. If the stub-through is used simply to provide a pathway for cables to enter or exit a room, it may not be considered part of a larger conduit system. However, if the stub-through is integrated into a more extensive network of conduits, it should be treated as such, adhering to the aforementioned fill requirements. To ensure compliance with general fill requirements and to mitigate the risk of damaged cables, several recommendations should be followed. Firstly, select a stub-through with a diameter that is appropriate for the number of cables you intend to install. This will prevent overcrowding and potential damage to the cable's insulation. Secondly, avoid overcrowding the stub-through by leaving some slack in the cables. This allows for easier maintenance and reduces stress on the cables and their connections. Thirdly, secure the cables within the stub-through using cable ties or other approved methods. This will prevent the cables from shifting and potentially causing damage to themselves or other equipment. Fourthly, clearly label the stub-through to indicate its contents and to verify its capacity. This is especially helpful for future maintenance or modifications. For distributed antenna systems, or DAS, installations, there are some additional considerations to keep in mind. Firstly, use stub-throughs that are specifically designed for DAS applications. These stub-throughs are typically built to handle the weight and stress of the cables used in DAS installations. Secondly, route cables properly to avoid conflicts with other equipment in the phone closet or intermediate distribution frame, or IDF, room. Proper cable management will prevent damage to the cables and ensure easy access to other equipment. Thirdly, consider the electromagnetic compatibility, or EMC, of the cables and their proximity to other electrical equipment. Electromagnetic interference can disrupt the performance of the DAS and other equipment. When deciding on the size of a conduit, it's important to consider several factors to ensure it meets the requirements of the National Electrical Code, or NEC, and provides adequate space for the conductors it will house. These factors include the number of conductors, their size and type, and any applicable directing factors. Firstly, determine the number of conductors that will be placed in the conduit. This includes all current carrying conductors, as well as any equipment grounding conductors. Secondly, identify the size and type of each conductor. This information can be found on the conductor's insulation or in the NEC tables. Thirdly, consult NEC Chapter 9, Table 4 for conduit fill limitations. This table specifies the maximum percentage of conduit cross-sectional area that can be occupied by conductors. Fourthly, calculate the total cross-sectional area of all conductors. This can be done using the dimensions provided in NEC Chapter 9, Table 5 or Table 5a. Fifthly, select a conduit size that provides sufficient space for the conductors while adhering to the fill limitations in NEC Chapter 9, Table 4. This may require using a larger conduit size than initially anticipated. Sixthly, consider any applicable directing factors. If the conduit contains more than 3 current carrying conductors, the ampacity of the conductors may need to be derated, as specified in NEC Table 310.15. This derating can impact the required conductor size and consequently the conduit size. For example, let's say you need to install 4 number 12 American wire gauge or AUG THHN conductors in a conduit. From NEC Chapter 9, Table 5a, The cross-sectional area of a single number 12 AWGTHHN conductor is 0.133 square inches. Therefore, the total cross-sectional area of the 4 conductors is 4 multiplied by 0.133, which equals 0.532 square inches. Consulting NEC Chapter 9, Table 4, the maximum fill percentage for more than 2 conductors is 40%. To determine the required conduit size, you need to find a conduit with a usable area that is at least equal to the total cross-sectional area of the conductors divided by 0.4. In this case, 0.532 divided by 0.4 equals 0.133 square inches. Looking at NEC Chapter 9, Table 4, a half-inch electrical metallic tubing, or IMT, conduit has a usable area of 0.304 square inches, which is sufficient for the 4 number 12 AWGTHHN conductors. Therefore, a half-inch EMT conduit would be suitable for this installation. Remember to always consult the latest edition of the NEC and follow all applicable local codes and regulations. It is also recommended to consult with a qualified electrical professional for guidance on specific installations.